Cool. I'm going to talk about Ajax and fetch, right? So not this one, but I leave this here because I just need the acronym. Not really. So does anyone know what Ajax stands for? Oh, I didn't like zoom in on the answer. Oh wait, where is it? Oh dang, I don't have it in here.
Asynchronous JavaScript something.
That's all you need. Asynchronous JavaScript something. It might as well be called AJSS, right? Cool. What it stands for is asynchronous JavaScript and XML. XML is a markup language very similar to HTML that is not as popular as it used to be. And so you can just think of it as the way it's written is very similar to HTML because it's like a markup language. So you can do stuff like this, right? So XML kind of looks like HTML. You kind of have like a p tag, and then you have like this is a paragraph, yeah? And then you close it out. Oops, you close it out, right? No big deal. You all see that? You just boop, 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 boop. Is that more better? Cool. XML is, imagine you can wrap something, right, in something like maybe like a p tag, an a tag, and that just represents what is supposed to be inside there. So like let's say I wanted to send you an email, right? And in the email I have a subject, and then I put like this is the subject. And then I just simply close it out. And then guess what else email has? Like a message body. So I can put like body. That's HTML. Message body. Boop. And then just be like, yo dog, you free this weekend? Lols. Do you guys remember this? This was popular at some point. I don't know what happened to it. Didn't like it. Never used it. And then you end message body. So not to get really into XML, but this is kind of like what it looked like, just like so you have an idea of what it looks like. The problem is if I'm sending these requests back and forth, what do I really want? Do I want all of this, or do I really just want this data right here? Just the data, right? And so you can imagine this 2 lines, I'm already sending how many extra characters? It becomes really bloated. And so kind of XML, while still used pretty often in today's world, has fallen out of like the main favor. Today we use something called Json, which is JavaScript Object Notation. Really what it is let's say you're writing Ruby, you're writing some Python, you're writing in JavaScript, C, Java, anything like that. Data needs to come across on the internet somehow. What we've like done as like the internet, and I say we, I mean like all of us, because now we're all developers now, is that we needed some sort of language agnostic data structure. And so every single language will have a data structure that looks like this. Whether you call it a dictionary, a hash, or an object, it's these curly brackets, or the curly boys, that has a key that simply points to a value. So what we use now is JSON, and it just looks just like this. It's a hash, it's an object, it's a dictionary. Whatever language you have, right, will be something like this. And so we pass this back and forth because there's not a lot of extra stuff getting passed down. And so we can save on how much data we have to download by not having to wrap everything in like extra text. It's just boom, curly brackets, boom, give me the data I want. Right, and that's the idea behind it. So let's talk a little bit about Ajax. Are there any questions on like Ajax and like what this like XML kind of stands for? We still call it Ajax, but very often it's not actually XML. Cool. All right, so what we're going to learn about is why we write asynchronous code in the first place. All right, so we know this. JavaScript is a single-threaded programming language that is non-blocking, meaning it just reads top to bottom and it'll execute the code from top to bottom, left to right, very much like Ruby. So let's take a look at some of our favorite code in Ruby. Look at that. So it does these 3 things first, right? It requires some gems, and that's going to be the REST client, which I'm going to use to make a request. It's going to require this gem called JSON, and then our good friend Pry. Right? You guys familiar with Pry? Best friend. Cool. So this is all it does, right? cool. It's gonna put, I'm gonna take a quick nap, BRB. You guys remember the last time you said BRB? Never for me. I mean, I'm always connected now, right? My phone's always on. I never had to be like away from keyboard because like, guess where it is?
That was the thing.
That was a thing. You remember? I know. Do you remember like the 100 free hours of internet? Oh man, powerful. All right, cool. I don't know what this is doing here. So cool. So what I'm gonna do is I'm gonna run this sleep function, right? And sleep, all it does is literally just, it tells the app like, just chill out, hang out for 5 seconds, don't do anything, and then come back and do something. So it says, okay, cool, I'm awake now. And then I'm gonna make this REST client request. So all I'm gonna do is do REST client, and what type of HTTP verb is this REST client gonna do?
Yeah.
Yes, very good. Just a lucky guess, I'm assuming. So REST client is gonna make a GET request to this particular URL, and let's see what we get when we go to this URL. Bloop, 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 bloop. Have you guys seen Parks and Rec?
Yes.
Cool. There's a guy named Ron Swanson. He just says a lot of weird things, right? Like, look, Tom put all my records into this rectangle. I think he's talking about a computer. But either way, so what type of data structure is this? It's an array. So here we can see it's just an array. All I'm going to do is make a request to it, and it should give me back this array. That's kind of what I'm expecting here. So let's do this. Let's drop a binding pry. Bloop. Let's drop a binding pry because it's our friend. And we'll pause the code right here, and we can test our assumptions. So let's do that. Boop, boop, boop. I'm going to run Ruby, and this file is called sync. So I'm going to run it. So I'm going to see literally this right here. I'm going to take this quick power nap, sleep, wake up, make the requests, and then it's going to hit the binding. Cool. So let's take a look. Let's clear this out. And it's simply going to go taking a quick nap, and it's going to wait for those powerful 5 seconds, and then eventually it's going to wake up, and it's going to make the request. So those 5 seconds, right, did any code run while sleep was running? No, it didn't. So the sleep is known as blocking code. Like while something is happening, nothing else can be running. So that's considered blocking code. So let's take a look at this request, right? I've stored it into a variable. And so when I actually investigate this variable, what can I assume to receive? What can I think it would possibly be? Right? Who thinks it's the array? Close, okay. Now let's think about this, right? I did restclient.get. Do you remember mod 2 when you did bcrypt password like new? What did you get back? What did you get back with the bcrypt? Yeah, with bcrypt password.new. What type of object did you get back? A hash? I would say when you did bcrypt password.new, you got back a bcrypt object, right? All right, you got a bcrypt object, right? If I had a dog class and I did dog.new and I put in like for a name cookies, what would I get back? The string cookies, or I get a dog object? So here, this restclient.get, and I pass in this string here, and it's going to go make that network request for me. What can I now assume this might possibly be? REST client object, right? That's what it is. So I could take this REST client object, and I could see like, it's in there somewhere, right? The array that I want, the value that's in there is somewhere in this object. And so, like I said, when we request data over the internet, typically what can be passed back is one of these things called Json. What I can do is I can take this, and I could put to JSON. I'm sorry. It's JavaScript. It's too powerful. I can go json.parse, and I can pass in this object. And what it's going to do is going to convert it from this like REST client object into JSON for me. And now I'll have the array that I actually want. So it's important to know the the object, the type of data you're working with, and then you can manipulate it, right? It's always tricky because what if you're comparing the string one to the number one? Will that ever work? Strict equality, sorry to be more specific. No, it's not going to work, right? So you always want to check the data type that you have, and that's like really important. And so here we have, this is the array that I'm getting. Now I can actually do something with this array. If I really wanted to, JSON.parse is so nice that it will actually even convert it to what I think it is, and that is the actual array. So can I run .each on this? Yeah, absolutely. It's the array class, right? And it has all the array enumerables available to it. And so that's really like this whole thing. Just understanding that I can make a request and I should be getting some sort of response. Typically a response object, and then I can go through that response object and make sure, test to see, am I getting what I think I'm getting back? All right, cool. Any questions on blocking code and checking what your response should be? Good? Airborne. Now let's write this exact code, but in JavaScript. You guys like that? I always like. Yeah. We had an instructor here named Andrew. And he would always look like, I finally described accurately what he was doing. It always looked like he was like sneezing before he said something. He'd be like, oh yeah, I love JavaScript. And I'm like, man, me too. All right, so unfortunately, JavaScript doesn't have a built-in sleep function. So we had to make one up. Don't worry about how this is working. This is very complicated code, very complicated. And essentially all it does is it runs this while loop for a really long time. It's very complicated. Mathematical algorithms, all that. So the idea here is that this while loop is also blocking, right? Like this while loop is going to basically try to count all the way until like I is like greater than whatever this number is, which is like kind of like an insanely high number. The problem is like the computer calculates I so fast that I had to make the number really high to kind of like pseudo create this sleep. It's not perfectly accurate, but it's good enough, right? So what I want to do is I want to console log, hey, yo, I'm going to take this quick power nap, and then I'm going to run this sleep function that I just did. And then I'm going to console log, wow, that sleep function took forever, 1 star. So let's take a look to see how that works. What I can do is I can simply open up the Chrome DevTools. And what I'm going to do is clear this. So when I refresh, it's going to run that sleep, and we're going to take a look at how the console logs are being affected by it. Okay, that's embarrassing. Oh, that's right. It's HTML. Embarrassing. Bloop. So I started the sleep function, and this is going to go to sleep for a little bit, and it's going to count to like 1,000 or whatever, I don't know. And then, wow, that took forever. What a terrible user experience, right? You ever been on a website where it loads, and then when you try scrolling, it's like, it's got to load all the images first, and then like all of a sudden, like all the scrolls happen all at once at the end there? It's like, yeah, that's not great. And then it's like the performance of that website, no bueno. So let's take a look at what's happening. I have this click button, right? And right now, let's take a look at what it does. Oh, huh. Thank you. Bloop, bloop, bloop. Is that better? Huh. Man, computers. Complicated. All right, if I click this button, right? Let's just take a look and see what happens. Bloop, 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 bloop. Bloop. What does it do? Huh? If I bloop. It does not. This does nothing. Very good. So let's just make it do something, right? Cool. I could take a look at the HTML. Wow, blocking. 1 star. Take a look at the HTML, right? Where's that button anyway? Where's that button? I know you're nodding, but just can you help me identify this button real quick? Under my mouse is very, yes. I'm on hovering over it. Very good. It's like the button tag with the ID of button click, right? So let me do that. Let me go grab that real quick. Let me talk to my boy. Get element by. Should we use get element by or query selector? It's up to you. Nose goes. Query selector is powerful. Let's use that. Cool. Boop. Oh, embarrassing. And that was, whoa, strings are out of control. What was it again? Click button. Wow, what a good name. And then what do I want to do? Yeah, save as variable, so I have access to it later as a reference, right? And so little const, little button, click button. No? All right, nobody liked that really bad Drake meme impression. Cool, so we can take a click button, and we can add an event listener. So good. Oh, all right, cool. It's hard to like type and think and code at the same time, so my spelling will get really bad. So when I'm like making that face, just let me know if I spelled it correctly or incorrectly. That'd be very helpful. All right, cool. And what am I listening for? A scroll? Powerful. And what do you want to do on this click? What is this called again? Wow, now you're getting it. See, it takes a little time. And by it takes a little time, I mean like 3 days. So it's like actually super fast. So in this callback, all I want to do is let's just log eat. All right? You want to say bloop? All right, bloop. Bloop. All right. Thank you. I like that suggestion. Cool. So on refresh, right? Remember, it's gonna console log like, yo, I'm gonna take this quick power nap and BD, and it's gonna run the sleep, which is blocking. And I want you to listen for the actions that I'm taking on the page, and I want you to observe exactly what's happening. So I'm gonna refresh, and I'm gonna click. Wow, did you see any of those click actions happen while the sleep was running? No, but what happened when the sleep finally finished running? All the clicks happened all at once, right? When you're browsing the web, we were surfing the web, remember that? Surfing the web, oh my God. We were surfing the web, and this is like back in maybe like the early 2000s. You ever like do a bunch of things and the website's like, oh, hold on, I'm still loading, and then all of them happened at once? Yeah, that's what's happening. That's what's happening here, right? That's a 1-star user experience. That's not a great user experience. And so what would make sense is there any way that I can make this like sleep function sort of happen in the background? And so like the rest of my code is not being blocked. And that's really what asynchronous code is kind of doing and what it's all about and why we use asynchronous code, to basically create a better user experience. And that's all. Any questions on like why we decided to use asynchronous code? Right? Like, do you want this 1-star website? Like, no, it's terrible. So let's figure out something. What I want to do is the functionality that I want to have is just even on my HTML is I want to make this request to this Ron Swanson API, get back this quote, and then slap it on the DOM. But what I don't want to do is have this network request, like this API request, prevent anything else from happening on my website. I still want, while the network request is happening, I still want the user to scroll, I still want the user to click, I still want the user to type inside a form, and I don't want to block them. And so I'm going to make sure that this request is asynchronous. Because do you remember in Mod 2 when you started your Rails server and you're like trying to get to the show page and you're looking at the terminal and it's like started get to animal/1 and you're like, all right, man, come on, let's go. Let's go, dog. Let's go. And then finally it loaded. And then other times it did a get to /animals and the index came back instantly. Right? Just knowing that, can you accurately determine how long a network request will take? No, absolutely not, right? Sometimes it takes 1 second, sometimes it takes 3, sometimes it takes like 5 or 6, and you're like, what is this? The 90s? It's crazy. And so what we want to do is we want to make sure that when we make that network request, it's not blocking anything else. All right, so let's do that. So here, how how can we make a network request? What do we like talk about this morning? And by we, I mean you all, in terms of just the discussion question. How does JavaScript make a network request? What is the method that I'm looking for? Right, fetch. Cool. And fetch will take, oh man, that's embarrassing. Fetch will take a couple arguments, right? But what's the first argument for fetch? Well, what should be like kind of like the first argument if you're like making a network request? What do you think it might be? Right, like where, right? Like you're telling literally JavaScript like, hey, go fetch some data for me. Go make this network request. The first thing it wants to know is like, but where though, right? And that makes sense. The second is going to be, well, the second's very complicated, but what we can do is take a look and a hint. All right, REST client knows what type of request to make. Does the fetch know what type of request to make? Not really, not until I tell it. And so the second argument, it gets more complicated, but one of the things in the second argument is just going to be the method. And the first thing I want to tell it is get. So the most common network request that we know about is a get. So naturally, if I do not have this here, it will still work. It will just default to get. It'll just assume you want to get. I'm going to leave it in here to be just a little bit more explicit, and we're going to play with this, and we're going to break it, and we're going to explore it. All right? So the first thing I want to do is I kind of want to do exactly what I did with this Ruby sync, and that is store it into a variable, and then like take a look at what it is. Right? So let's see. Oop. So let's see. Question? Oh, sorry. So const, and that is like quote equals to this fetch. Then all I want to do is console log the quote. Right? Nothing crazy, nothing wild. Let's see what we. Let's get rid of the sleep. We don't need that anymore. 1 star. Let's take a look at what we get. We get something back called a promise. So fetch returns what? What does fetch return? Fetch returns a promise. Cool. And in this promise, we could see something called. We can kind of see the details of this promise, right? This promise status and a promise value. So the status is resolved, right? There's really two sort of things that a promise can do. It can either resolve, right, meaning like, hey, I made this network request successfully, or it could be rejected because you passed me a bad URL and I have no idea where the heck that is, right? If I wanted to go to like evanswang17.com, it'd just be like, ooh, the network request was rejected because that site doesn't exist, right? Here, the site does in fact exist, so naturally you would see something like resolved here, like this promise was resolved. And then you get this promise value, and this promise value is a response. In the same way that the REST client.get gave you back a response object, and in that response, there's a lot of information in here. All right, we're not going to dive too much into this right now, but really, this is kind of like all you really need to know, that there's some sort of status, either resolve or reject, and that if it's resolved, that there's some sort of response there. So knowing what I know, right, I should probably do what? In terms of, like, I don't understand a promise, what can I do? I can Google it, right? Then you, at this point, as a developer, you'd look up like, hey, what is a promise? But here in lecture, I'm just going to try my best to explain it to you. But what a promise is exactly what it sounds like. And that is a promise in real life. Like, yo, man, can I borrow this 50 bucks? I'll promise you I'm going to give it back later. Oh, no? I see what you're saying. Thank you, man. Thank you for the trust. You're good dude. So this is what I want to kind of like draw for you. All right, so let's do this real quick before I get into that. Let's do this. Great. So on this fetch, right, I get back a promise, and that promise, in order to access the response for a promise, you have to ask for it to say, hey, look, I know you're going to go do this thing, and you promise to come back with some data. When you come back from that response, request. You're off somewhere in the internet. You're surfing the internet. You come back. Once you come back, then I want you to do something. That make sense? Like, hey, you're going to go make that request. You're going to hit a get to /animals. Whenever you're done, then I want you to give me that data when you get it. Right? And that's kind of what that event loop is all about. I can attach literally a method on a promise called then. But this already you could tell, like, it doesn't look very sexy. So JavaScript is space agnostic, meaning if I add a couple extra spaces, like return lines, doesn't matter. I can call then right here. Then is going to still be attached to the fetch. Cool? It's just easier to read. When you push your code to production, it will go through something called like a minification process, which it will just literally remove all of the extra white spaces to make the file as small as possible. But in terms of human readability, developer to developer, sometimes it's easier to just put it on a new line. All right? So here you have a then, and the then will look for a callback, because what is then really? It's like, hey, once you get that response, then I want you to do something. And like I said earlier, how do you tell code to do something? Yeah, you type it, but you write a function, right? Functions and methods really tell code what to do. And so naturally, then should receive what? Like a callback function, right? So imagine just in this like human being scenario, I'm like, oh, hey, can you do me a quick favor? Can you go and like grab this piece of paper for me? You'd be like, cool, got you, fam. You're gonna go, you grab the piece of paper, and then you're gonna stand right here, and then I'm gonna look at you. And you're gonna be like, what do you want me to do? Do you want me to give you this paper? Do you want me to like throw it at someone? Do you want me to make a paper airplane? I'm gonna have to tell you what to do once you're done with that task. So this will receive a callback function. Below this, boop, 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 boop. All right, this function, right? This callback function. In the same way that the event listener received the event, this callback function should receive what from this fetch? And just in your mind. This fetch went to go get some network data, and now it's back and it has the network data and it needs to do something. So in this callback, it should probably receive what? Right, the response, right? Like what actually came back? It makes total sense. So I'll have response here. And then before we do anything else, I'm going to just try my best to console log the response. All right, now I'm going to test. So let's test. Boop, boop, boop. Let's see what it is. We can also get rid of these console logs. Boop. And there it is, right? It's exactly what I think it is. Let me help you out here. Cool. I have a fetch, and it console logs this response. And guess what it is? It's a response object. In the same way that Ruby gave me back a response object, I need to do what with it to actually get the data that I really, really want. What did we do in Ruby? What did we do in Ruby? We had to parse it, right? We had to run this like Json parse sort of functionality on it. So here, all I'm going to do is just go, response. So it's a little different, obviously. Ruby, it's just going to be JSON. I'm just going to like invoke this method called JSON on it. Let's take a look. That's weird. It gave me back another promise. Interesting. Interesting. This one's resolved. But now look at what the value is. The value is the array. That's the return value of this response. But it's also a promise. So fetch gives me back a promise, and then gives me back a promise. So you'll hear this like really terrible joke. I tell it all the time. Nobody laughs. Not even in the last class. They didn't laugh last time. It's no big deal. But a promise will go on forever. Cool. Thank you. Thank you. Yes, just 2. Better than last time. It was 0. I think I learned something. I'm just going to stop saying that joke. It doesn't work. So fetch returns a promise, then returns a promise. And just like with the fetch, how did I have access to the promise returned value? What method did I call to get access to the promise's return value? I used the .then, right? So .then is a method on a promise that receives a callback that allows me to get access to it. So here, this console log, what does console log return? What does puts return? Puts will simply put to the screen, like print to the screen, and console log will log to the console. But what is the return value? Undefined, right? So let's not make that rookie JavaScript error, and let's actually return this JSON, right? That means that in order to get the response value, this returns something. And now that this returns something, I can, if I wanted to, put it here. But I'm a dirtbag and it doesn't look like it reads very well. So I'm going to put it here. It's nice and sexy. And then the then will receive what as an argument? Huh? That's part of it. But then, okay, you're right. That's actually the correct answer to my question. Then will receive, yes, the value. But what does then take as an argument? It takes JSON as an argument? What does then take as an argument? Callback. Oh, I got crazy. Callback function. Cool. And just like this received the response from the fetch, what was the return value of this function? What's the return value of this function? The value. What is the return value of this right here? What is the return value? What is the return value? Yeah, an object, but specifically what? The array. Yeah? Can you guys see that? Cool. So that means that this is going to receive the return value of the previous promise. So what do I want to call it? What would you call this? What is this actually? This is like the quote, right? The promise's return value is an array, and in that array I have one quote. So it makes sense to name this like kind of whatever I'm expecting to get back here. The return value of this promise is going to be what gets passed in here. So I'm going to get back a quote. At least I think I am. So let me just, without further ado, console log and a quote. And see what happens. Bloop. And there it is. This is the quote. This is the actual working data that I really need. I shouldn't? I should? Okay. Okay. There we go. That's fine. So remember, then, right, returns a promise. It receives a callback. And what it receives is the return value of the previous promise. So the return value of this fetch is a promise. It's basically the response. I can parse the response. And when I return this promise, it's the actual value that has been parsed into JSON, which then goes into the next then. And this is what I have here. Knowing what I know now, if I wanted to return something silly, right? If I wanted to return like, I don't know, hot dog. If I wanted to, right? Remember this then, this then will return what? Yeah. That's the return value. But what does it return though? What type of object? A then will return what? And what does fetch return? A promise, right? So on that promise, I can call then again. It takes a callback. It's going to receive the last return from that previous promise? And what is the last return? What did the last promise return? Okay, so what should this be? All right, this is very complicated. All right, there's a lot of things that I said to you, and I saw some nodding, but also a lot of quiet faces. Help me help you. Where am I losing you? I'm gonna ask a couple questions. Just a quick thumbs up if that made sense or you understand it. Ready? Fetch returns a promise. Cool. On a promise, there is a method available to it called then. Then receives a callback. I mean, as an argument. Callback as argument. Cool. What it receives in the callback is the return value of the previous promise. Cool. Because of the fetch, it's the response object, and then I parse that into JSON. Right? From here, this then returned what? Another promise, exactly. Which means that I can then chain another then on it, because then is a method available to promises. And this callback receives the return value of the last promise, which was the response that I parsed into JSON. And that, I'm assuming, is like an array of a quote or something like that. And then, sure. This then takes a callback. And in there, the argument to the callback is the return value of the previous promise, which we looked at. We looked at this response. It's a response object. I parse it into JSON, and then you could see that the return value there is an array. So once I parse it into JSON, in order to have access to that return value, I have another then that receives that return value, which is like the array. I called it a quote because in that array I know that there are quotes in there. And then earlier I console logged quote. Do you remember? Which was basically the array with one quote in it. Then just for fun and just for demonstration purposes, I added another then just to prove that it receives the return value of the previous promise. So do I really need this then here? Or do I currently have access to the data that I really want and need? Right, so this is trash code. But good for demonstration purposes. Cool. Yeah. All right, so let's take a look. And again, it's that array. Let's talk about something here, and I will draw it out for you using my very good, good artistic skills. I think some of you were able to discuss this in the discussion question. Oops. Boop, boop. Are there any questions as to whether or not this is actually before and after the fetch call? No, right? Right as rain, clear as day. So here I'm console logging the quote. Reading it from top to bottom, left to right, I should expect this console log before the fetch. I should see this fetch execute. I would assume this console log appears. And then after the fetch. Only I see before fetch, after fetch, and then this log is executing. Does anyone know why? Asynchronous, sure, yeah. Eat. Does anyone want to care to explain? Or you can just hear it from me in like 4 seconds. Just wait there quietly.
Well, isn't it because like normally it goes top to bottom, but when it's asynchronous, it has to
Yes, exactly. And so what he said was, normally it reads top to bottom, left to right, but once you run asynchronous code, it happens in the background, and then it's like unpredictable as to kind of like when it comes back, so to speak. But let's add some clarity and be able to successfully predict what's going on. So let's do that. Oh man, all right, wish me luck. Cool. So there's something called the call stack, right? You've heard about this in the JavaScript, the weird parts, and this is how JavaScript will execute your code. I'm just going to draw this right here, this little like container, and we'll call this a stack. So this is a type of data structure. So I'm slowly introducing you to these like computer science concepts. The other day we introduced like nodes and trees, and like how the DOM is a tree. It's like a type of data structure. This one is called the stack. Does anyone know how the stack works?
Well, I was gonna say, I guess like for every whatever, I guess methods or whatever you're pulling off, like there's a certain order to them, and they all get like done in a particular order.
Yeah.
Based on how they get received in the stack.
Oh, you could say that. So a stack you could think of, right? It only has 3 methods. The 2 that you really need to worry about are called push and pop. And that is, if something goes in, right, it kind of hangs out here, I can do one of 2 things. I can either push another thing on there, I could push another thing on there, or I can pop it and take it off. That's it. Just push and pop. Well, there's one more method, it's not important. So the idea here is that you could think of it like pancakes, which is the metaphor I like to use, right? Unless you're an absolute savage. Let's say I have these 4 delicious buttermilk pancakes on here. Is there any way that I can actually eat this bottom pancake without having first removed these top 3? I mean, you know, we're not talking about using the fork and just cutting all of them. We're talking about like actually like reaching down and like grabbing the bottom pancake, like without being an absolute savage, right? Is there any way I can reach that bottom item? No, the top 3 need to pop off first before the bottom one can be reached or realized or completed, whatever you want to call it.
Why do you think the kids do half cycle? You can pull it from the bottom.
You could, but you would knock over the entire stack.
Yeah, then you would be being a savage, you know, it's just not the right answer here. We're not barbarians. It's 2019, we're developers. And so the idea here is that JavaScript runs the same way, all right? So if something goes in, the first thing that goes in here, right, has to be the last thing that comes out. Think about it. This first thing went in, right? I cannot pop this out until this pops off. So when the first thing goes in, it has to be the last thing that comes out. So first in, last out. It's called Philo, right? First in, last out. Any questions on Philo, the stack, delicious pancakes, Aunt Jemima? Okay, sure. Aw,
Sorry.
it means weak when you say it. I'm just kidding. I'm just going to assume powerful is an exception. So powerful. All right, let me just erase all this over here. I got to make this bigger. All right, cool. So let's take that exact example and understand how JavaScript runs your code. Let's just say I have, I don't know, a console log. All right. Let's do this instead. Ready? I have function, and that is like function 1. Boop, boop. And what that is going to do oh, wow. Did you see that? Embarrassing. I have 3 functions. Function 1 is going to invoke function 2. Function 2 is going to invoke function 3. All right? don't worry about like, me not passing it in as a callback or anything like that. That's kind of like not really what the point of the story is. The point of the story is that function 1 calls 2, which then calls 3. Cool? So the first thing that happens is JavaScript will read your code and it'll see, oh look, there's a function here. I'm going to put it on the call stack. All right, let's do that. This is not going to work, by the way. But let's say function 1 gets invoked. So function 1 will fall on the call stack, and it's like this amazing pancake right here. Function 1. And what does function 1 do? It calls function 2. So is function 1 complete yet or no? Is it done? No, it's still running. And so what it does is it calls function 2. So I have function 2 here. That's why I brought a mouse to this lecture. This on the touchpad would have been insane. And then function 1 calls function 2. So function 2 pushes onto the call stack. Right? A little F2 action. And what does function 2 do? It calls its boy function 3. And that pops on the call stack. So function 1 and 2 are not technically done yet because function 3 is still running. And so can function 4 ever run if 1, 2, and 3 are all on the call stack right now? No, JavaScript will not read and execute the next line until it completes what it needs to do. So then function 3 returns like, hey, you're cool, and the return keyword means that the function is complete. If the function is complete, whoa, that's big. Function 3 is complete, and it pops off the call stack. Oh, I feel like Goldilocks. That's just too small. And then once function 3 is done, it returns. It goes back into function 2 to continue running. Let's say function 2 hits a return, and then that's done. It pops off the call stack. And then function 1 is also done. It returns, and it pops off the call stack. All right. The call stack is now clear. It's now clear. Now JavaScript will run the next line of code, which would be like function 4, maybe a console log, maybe a fetch, maybe a sleep function that you just made up, like a boss, whatever, no big deal. All right. It will just run the next line of code. Are there any questions how like JavaScript is sort of like reading, executing your code, and what the call stack is used for? Awesome. So this is what happens, right? Let's just say you have function 1, and function 1 is like a console log, right? What it'll do is function 1 will pop on, it console logs, and then it finishes, it's done, and it pops off. Cool. What's the next thing JavaScript will do? It'll go down to the next line. It's synchronous. It reads top to bottom, left to right. And let's say function 2 is a fetch, right? Fetch goes on the call stack, and it hangs out right here, and it runs. As we know, these network requests can take a really long time, and we don't know how long. Do we want our users, we want to block the call stack while the network request is happening? No, we don't want that, because as we talked about, that's like a terrible user experience. So how can I get this fetch off the call stack? I can return. So if I return the fetch and it pops off the call stack, I know that function 3 can then go on the call stack and continue running my code. It makes it so that the fetch is non-blocking. But here's the thing, I need the fetch to actually still run somewhere. I still need it to make the network request and get the data. So what fetch will do in order to pop off the call stack is immediately return a promise. And that's why fetch returns promise. It says like, yo, I'm gonna go grab that data, MBD, let the call stack continue running. So here's what's happening, right? You have a console log before the fetch. You have the fetch that goes on the call stack, immediately pops off because it returned the fetch, and then you have function 3, which is the console log. So if you had something like console log before fetch, you had a fetch return a promise, and then you had something console logging after the fetch. You might see before, after, and then this sort of fetch goes somewhere nebulously. We have no idea where it goes. This is where that event loop video really kind of comes into hand. And that is, where it goes is into the event loop. And that is, Chrome will now handle what's happening. Chrome has its own like API, and it will do the network request. And then it will come back when it's done and sit in the event loop, right? I'm just going to draw it very similar to the video. And so the fetch pops off, and it goes into some like, queue in here. Once it's done, right, it actually gets the data. It finishes. It goes into the loop. And then the loop is a very polite individual and does not play line cutsies, doesn't jump the call stack, doesn't go on until all of the JavaScript is done. When the call stack is completely clear, there's no other code to run. It's like, oh, the call stack's clear and empty. I'm ready to receive anything else that happens. Then the fetch will go, oh, cool. Yo, there's nothing on that call stack. This is empty and clear and clean. You finished running all your JavaScript code. Awesome, cool, great. This comes back with the data. And what do you do with that data once it comes back? Well, then you run the callback. The then callback runs at that point. So you have the before console log. You have the fetch that pops on the call stack, pops right off because it returns a fetch. You have the after console log. Then it runs all this code, this cool code. The call stack is clear now. All the way at the end, the bottom, the then comes back, which is the console log of the quote. So, would this make sense to you now? If you see something like this, where you have, okay, this is going to break it. You have a console log before. You have the fetch that goes on the call stack, goes into the event loop, right, because it returns a promise, hangs out somewhere else. JavaScript continues running the code. It doesn't block it. You see after the fetch. Then it runs the rest of the code here. The call stack is clear at 109. There's nothing else to execute in your JavaScript file. The call stack is clear. The event loop's like, oh, cool, you're free. The data comes back. Once the data comes back, it then invokes your function. It parses the JSON. Call stack is clear again. Then it will console log the quote. So you see, before the fetch, this returns a promise, goes to Neverland. After the fetch, call stack is clear, comes back with the data, then it does it. So you see it actually come back in this order. This is the hardest part of JavaScript because the code no longer runs and reads and executes in the exact order that you wrote it. This is the hardest part. If you can understand and manage this, you'd be good to go for async. Now, are there any questions as to why it comes in this order? Why fetch would return a promise? Why would fetch return a promise? Yes, but specifically, take it off the stack so that it doesn't block, so that the click handler still works, so the scroll still works, so images can still load, so I can slap stuff on the DOM. Right? And then it'll do it once the call stack's clear and it gets the data back. So the important thing to note here is that even if this finishes early, but Java is still running a bunch of code, it's just going to hang out. It's going to be like, cool, oh, do your thing, no worries, it's fine. And then once the call stack's clear, the then response gets invoked.
I don't know if it's sorry.
No, please, and then I'll give it to your question.
I was going to ask, like, does the call
How polite of you. How event loop polite of you.
Does stack still get cleared like if your fetch is like within a function that hasn't finished like running? Let's say a function calls another function. Like, what happens then?
Once it gets to the fetch, right? Remember, fetch is a function, right? Technically a method, but it's a function here. You see these bananas? Is fetch being invoked right here? If a function invokes a fetch, what will fetch do? It'll return the promise. Then that function is technically complete. The higher order function is complete. And then the rest of the code will run. But remember, now that data is like in the event loop and Chrome is handling it. And then the call stack keeps going. The JavaScript keep running. Is that good? A good question. Did I answer it though?
I can't visually see it, but I guess so.
Okay, we'll try it. Ready? I have a function and it does my fetch. Boom. Cool. So now, because it's wrapped in, does fetch execute right now on its own independently? No, I have to do this. Yo, do my fetch. Bloop. Now, 38 will run, goes on the call stack, runs the fetch runs, returns a promise, that's done, does my fetch is done, then console logs. Is that a good visualization?
So what do you think? Like, does it pretty much...
Hold on. One thing at a time. Did that answer the question?
It worked.
Cool.
It's just like, are you saying that it's wrapping in a function, you're essentially doing the same thing?
I'm essentially doing the same thing.
Okay.
Yeah. I just wanted to visualize it for him because that's the question he asked. Good question. What do you mean? Like, you want it to run? And then you had a question because you so politely waited. The call stack is clear. Good sir.
Thanks. My question is, what if you have multiple fetches?
Ooh, that is a very good question. The question is, what if you had multiple fetches, right? If I had 5 or 6 fetches, they all return promises, then they all hit this sort of event queue. Then the weird thing is like, how can I guarantee which network request finishes, right? Is it request 1 that finishes first? Is it request 2? Is it request 3? We don't know. But when they do finish, they go on to the loop. So even though I have fetch 1, 2, and 3, it doesn't mean that they are guaranteed to come back in order of 1, 2, and 3. I'm not going to dive into this today because this is intro to fetch, right? But that's a very interesting question. If you wanted to, I would look into handling all of those fetches, which all return. Right. So there might be something called promise.all. And then that's like a really good blog post. And then being able to juggle like asynchronous code, lots of them happening all at once. The tricky part is, what if network request 2 depends on the return value of network request 1? So for example, like I wanted to make a Google search query on a book, but I don't know what the book is. I have to make another request to find out what's the book. Cool. I make that request, the book comes back. Now I have to plug that book into the other fetch for requesting data on that book. How do I juggle that? That is much more complicated. We will not be jumping into that today. But just so you understand how complicated it can be, this is the absolute foundations. Do you feel comfortable with asynchronous code? Just by a show of hands. Thumbs up, side, thumbs down. Oh, wow. That's an overwhelming, powerful response. Cool. Are there any other questions about just what's going on here before I start slapping it on the DOM? Yeah.
To clarify something you said before, like for myself,
Sure.
even when you had said that you were returning the fetch to take it off the call stack, you didn't mean to explicitly write return in front of the fetch.
Correct. I did not write return here. Because return technically is a promise. Hold on. That was this is the console log. I'd have to console log this. It's the promise. When you're doing some of the labs, it kind of forces you to do this. I don't really want you to get into this at all because, again, asynchronous code is different. The tests run something called async await. Again, I don't want to talk about that. It becomes fairly complicated. Just if you can understand this syntax right here and then managing this is the extent of where I need you to be right now. All right, async await gets very complicated. It goes more into blocking code, promise.all, multiple requests. So let's just not dive into that realm right now. This is where I need you to be. All right, good question though. Thank you for clarifying that, and I think that was kind of helpful for some of you like writing labs. What I want to ask now is, how are we feeling about just this fetch, just this single-threaded async one request at a time? Good? Awesome. All right, let's start slapping some stuff on the DOM, right? Because I want to show you something kind of cool. So remember, this quote is this array. What I can do is, inside index.html, I have a div with quotes. So all I'm going to do is right here, and I'm simply going to do document.querySelector with quotes. I think it's quotes. Yep. Little const q action, little quote container. All right, this is going to hold all my quotes this one div. And what I can do is I can do a couple things, right? Let's do this. Let's just console log the quote container. Cool. I have a div with quotes, right? Interesting. Inside this div with quotes, I have what inside? I have a child, one child. It's a p tag. All right, let's do this. Let's you guys like pry? Powerful, right? If you just drop debugger, it is essentially pry. You can stop your execution of code on that exact line. So what I have access to here is const quote container. If you highlight over it, it kind of tells you a lot of information. The dev tools are too powerful. So let's take a look at quote container. It's this div with one child element. I can say, quote container, what is your inner text? Right? It's all the inner text inside of quote container, even if it's wrapped inside a p tag. Because technically, this p tag is the text that's between the divs. But if I ask for its inner HTML, what am I going to get? I typed it wrong on purpose because I don't want you to see the answer. I'm going to get what? What is the inner HTML of this div? What is the data type of this? A string. Can I do something like this? Can I add two strings together? Does it make sense then to do this, which is, oh, by the way, a string of one p tag with quotes? Can I also add another string that simply is another p tag that says number, who does number 2 work for? And I closed it. What do you think would happen if I added those strings together? How many p tags would be inside the quotes container? There's 2. This is called string concatenation, right? It's no big deal. You learned it in day 1, learned it in some pre-work labs. Even Ruby can do this. Power. So if I looked at the inner HTML of quotes container, what should I see?
Right now, I can focus.
What should I see when I open this bad boy? That's not right. Oh, that's right. I didn't do plus equals. You're right. That ruined it. Ruined it. All right. So you know I can concatenate. What does plus equals do?
That's changing the action.
It mutates the original, right? Embarrassing. What is quotes container now? It's 2 p tags. If I took this, right, let me clear it out. If I took this and slapped it on the DOM, what happens to the DOM? What happens to the DOM? It changes. So I can literally string concatenate HTML that I make on the fly, as opposed to doing document.createElement p tag, right, is equal to p. I'm gonna assign it to p. Then p.innerText is who does number 2 work for, and then take the quotes and then append child p. That is like a long way of doing it. While it is step-by-step methodical, there's also this way where I can just simply take the inner HTML, add on to it, mutate the original value, and say, add this extra p tag on here, and this is what it's going to say. This is a little bit tricky to wrap your head around, but who's feeling like super cool about this? Thank God I don't have to write document.createElement anymore. That was kind of trash, MBD. Let's go do this from now on. I can't tell. Yeah. Check or hold. Awesome. So let's do that. Cool. I have my quotes container. I'm gonna go bloop bloop. Else equal, and I'm just gonna add on top of it a p tag. That simply has the quote in it. Is this going to work? No, because what is quote? What should quote be? What the? Okay. What should quote be? Well, I probably want to do a little this magic, right? Oh, dang it. Embarrassing. Do a little this magic, and then do a little money action. But what is quote right now? What is the data type of quote? It's an array. So I'm just gonna hack it together right now. It's not the sexiest thing to do. Would that be okay? Well, let's find out. Oh my God, just yeah. Wow, thank you for paying attention. No, that'd have been rough. Oh, thank you. Cool. I can also add anything I want, right? I can add on top of this, right? Let's do this. Let's make this so that it's a little bit easily readable as I add more HTML. So what I can do is take this. As long as there's this one thing in here, it will recognize that there's more string. If I do this, JavaScript will do what is known as automatic semicolon insertion. And it would just go, oh, cool, you're done. And it would just like end this line. So you want that to just be like, hey, I'm going to start a string, and I'm going to just keep going on the string on the next line. So then I can do this. And then I can do p tag. If I wanted to, I can throw h1 in there for funsies. All right? Well, h1 action. And it says for funsies. Sure. Now let's find out. Bloop. For funsies. What attributes does this h1 have? Does it have ID on it? What about a class? Can I add a class to this? Where would I want to add it? What line would I want to do that in? Oh, okay, great. 41? Can I try maybe just doing... All right. Let's take a look. Bloop. Let's inspect that in element. Whoa! So, just the key takeaway here is that if you enjoy doing create element, creating the p tag, changing the HTML, you can feel free to do so. That is a very methodical way. It's very easy to think through that process. But what I did want to show you was sort of like another way. You can ask for its inner HTML, and you can always add to that HTML as a different way to sort of append child, so to speak. Cool? So to recap, this is the lecture that breaks people. All right. This drawing right here. Clear as day, right? Clear as day. Clear as mud, really. Great. We have functions that run. They go on the call stack. You want to keep the call stack clear. The fetch will return a promise in order to keep the call stack clear, which makes it non-blocking. Why we need the asynchronous code. Where it actually goes, like Chrome will handle it in the event loop somewhere, and then it will come back. Once it comes back, when the call stack's clear, then something will happen. What that then is up to you. All right? That's what that callback does. And so that's the whole thing in a nutshell. Async, Ajax, fetch, slapping in all the DOM with inner HTML. What are your questions?
How come you never charge your battery?
Oh, actually, this was at like 80-something%.
Oh.
But I use it like a machine, and the screen recording also like drains the battery, and like I have a million tabs open. Yeah, I know. Brisket. Questions on the lecture material, and not obviously how like it in shambles my life is, right? So, okay, that's all I have for you today. Thank you. Thank you.